Hello everybody, today we're going to cover 3.6, which is derivatives of trig functions. Okay, so derivatives of trig functions are all pretty much based off of the derivative of the sine and the derivative of the cosine, and from there we could prove all of the others. We're going to verify these two are true graphically. So if we take a look at the graph of sine x, okay, so the curve that is right here. Right, and we analyze turning points, we analyze increasing, and we analyze decreasing, right? The derivative of that then must be cosine, right? We have our turning points becoming zeros, we have our increasing becoming positive, and we have our decreasing becoming negative. We could do the same exact thing with cosine. The derivative of cosine, they're saying, is equal to negative sine. So if we look at turning points, and decreasing versus increasing, right? We couldn't go to the left here and look at the positive sign because the decreasing portion of the cosine graph is positive on the regular sine graph. So that is why we need to negate it so that the decreasing of cosine is in the same place as the negative sine graph, right? And same thing for the increasing cosine is in the same place for the negative sine graph. Okay, so the derivative of sine is positive cosine. The derivative of cosine is negative sine. So that is the important stuff for this page. And we verified those two graphically. The other four are essentially given. We're going to verify tan x, but we won't verify the rest of them. You could go through and do the same exact thing for all of these. Okay. So in order to verify tangent x, we want to think of it as sine over cosine. Right, and then we can use our quotient rule. So we already verified sine and cosine using the graphs, and now we can use our quotient rule, which remember is f prime g minus f g prime divided by g squared. So the derivative of sine, I'm just going to notate this, original denominator, so cosine stays, minus sine x stays, we derive cosine x, divide by cosine x squared. Okay. So as we saw on the last slide, the derivative of sine x is cosine x, multiplied by the original cosine x that was there, minus sine x, times the derivative of cosine x is negative sine x. This is a good place for us to remember that cosine x quantity squared can be written as cosine squared x. It is not cosine of x squared, right? That is very different. So quantity cosine x squared can be written as cosine squared x. It's like the operation is being squared, not the input, okay? So that's how it's most commonly written. From there, simplifying the numerator would give us a cosine squared x, a positive sine squared x. Right. We have one of our Pythagoreans up top there, right? So that is equivalent to 1 over cosine squared x. And 1 over cosine squared x is, of course, secant squared x. So that just confirmed that the derivative of tangent x equals secant squared x. Okay. So tan x goes to secant squared x, secant x goes to secant x tan x, cotan x goes to negative cosecant squared x, and cosecant x goes to negative cosecant x cotan x. All right, so now instructions here, find each first derivative. So once you have them memorized, these types of problems, especially when there's no additional rule in there, super easy. So the first one, the derivative of f, 9 secant x, well, that derives to 9 secant x tan x. 12 cotan x goes to negative 12 cosecant squared x. And you're done. So I just replaced two rules there. The second one, I have to slow down a little bit, right, because it's a product rule. I have to acknowledge that it's x squared times cosine x, which means I need f prime g plus fg prime. Okay, so setting that up means I'm deriving my x squared, I'm keeping my cos x, plus I'm keeping my x squared, I'm deriving my cos x, giving me 2x cos x plus x squared times negative sine x. Clean it up just a little bit. 2x cos x minus x squared sine x. Okay, go ahead and give these two a try for a moment. Pause the video, try them on your own, and then compare your answers with mine. So the first one, you should have sine x plus 2 minus x cosine x divided by quantity sine x plus 2 squared. And the second one, you should be able to simplify to secant cubed theta plus secant theta tan squared theta. Okay, so now this question is asking us to take the problem that we just derived and now find the tangent line at pi over 4. Okay, so our derivative we just found in the previous example, so feel free to copy it down. Secant cubed theta plus secant theta tan squared theta. So remember, when we're looking for tangent line, we need our point, we need our slope, and then we can come up with our line. Okay. Our point is always coming from the original. Our slope is always coming from our derivative. And our line is the combination of all of this. Y minus f of a equals f prime of a times x minus a. All right, so we have our slope as a function, but we need to be able to figure out at the specific point of pi over 4, and we also need the point at pi over 4. So point coming from the original one, that's what we'll go to first. So remembering pi over 4 is that beautiful angle that gives us our root 2 over 2, comma root 2 over 2. Okay. So we need to know what is tan of pi over 4 secant of pi over 4. Okay, well, tangent at pi over 4, sine over cosine is 1. Secant at pi over 4, 1 over cos, is 2 over root 2, which would reduce to just root 2. It's 1 over root 2 over 2, or 2 over root 2, and you can rationalize from there. Now, I told you in calculus you don't have to rationalize. I wouldn't want the answer left as 1 over root 2 over 2, but if you gave me a 2 over root 2, that's fine. But you might choose to acknowledge that this one does simplify even nicer to just root 2. That's up to you. So our point is pi over 4, comma, root 2. Our slope So now we're taking pi over 4 and putting it into our derivative. So secant cubed at pi over 4 plus secant at pi over 4 tan squared at pi over 4. Okay, so we are cubing the output of secant pi over 4. Remember, so secant pi over 4 is root 2. So we're cubing root 2. And we're squaring 1. All right, so root 2 cubed, root 8, for me is the easiest way to think about that, which would reduce to 2 root 2. 2 root 2 plus root 2, so we get a 3 root 2 for our slope. So y minus root 2 equals 3 root 2 times x minus pi over 4. And you are done there. All right, last question of the day is to find the second derivative of f, where f is equal to x times cosine x. Okay, so f prime g plus fg prime is our product rule here, right? X times cosine of x. So the first derivative, we derive x, we keep cosine, plus we keep x, we derive cosine. So 1 cosine x plus x negative sine x, or cosine x minus x sine x. Our second derivative requires a product rule again, but the first term is not part of that product rule. So we can derive cosine x independent of everything. And then in this second set of parentheses is where our product rule comes in, right? It's minus this whole product rule. So x prime sine x stays, plus x stays, sine x prime. So negative sine x minus quantity, 1 sine x plus x cosine x. Okay, cleaning it up just a little bit, we have negative sine x minus sine x, so we have negative 2 sine x's minus x cos x. All right, so that is it for this lesson, 3.6.